So this lecture is in continuation with the previous lecture. Last time we have solved this problem. Problem number 3. This was a simply supported beam acted upon by one concentrated load of 120 kilonewton acting at point C, which was at 1.8 meter away from support A and 3.6 meter away from support B. Now, in the next problem, we have to determine the deflection at point D, which is a midpoint. That means if this total distance is 5.4 meter, then the midpoint means it is at 2.7 meter from either spot. Now, since there is no corresponding load at D point, so now look at this beam. Beam is same. The loads at C is same. So due to this load 120 kilonewton, the reactions are same 80 and 40. Since there is no corresponding load at D, which is the midpoint, to make the Castigliano second theorem applicable, the corresponding load P at point D is to be applied fictitiously. We will apply it imaginarily, fictitiously. So you can see the load P and the reactions due to this load with red color. So we will use the equation deflection at D is equal to 1 over EI integral 0 to L capital M into partial M over partial P into dx. Now, in the last problem, there were two portions, but in this problem, we have three portions: portion AC, portion BD, and portion CD. AC, first portion, origin is surely A, limit is same, 0 to 1.8. For portion BD, origin surely B, limit is 0 to 2.7 up to midpoint. Now for portion CD, we have the choice whether we take A as origin or C as origin. So accordingly, the distance x will be considered. So if A is taken as origin, the distance x will be measured from point A, and the section x will lie between C and D. Then the limit will be that this portion will start from 1.8. ये जो point C है, it is at a distance of 1.8 up to 2.7. But if you will consider C as origin, then its limit will be 0 to 0.9. So x will be measured from point C. But usually it is more convenient to consider A as origin, but it is still your choice. Now, the reactions 80 and 40 same as previous. The reaction due to this midpoint load P, imaginary load P by 2 and P by 2. Now we have to compute the moment expressions. First, the capital moment. Now for portion AC. The portion AC distance, take any section X from point A. So it will be 80 plus P by 2 into X, positive, because creating tension at the bottom fiber. Similarly, for portion BD, it will be 40 plus p by 2 into x. Same as 80 plus p by 2 into x, 40 plus p by 2 into x. Now for portion CD, little more concentration is required. So the x will be from A up to any point, up to any point between A and B. Let this distance is x. So it will be 80 plus p by 2 into x माइनस, अब ये 120 का लोड भी है, माइनस 120 इनटू x जो यहां तक है, ये डिस्टेंस आपने लेना है ना, x minus 1.8. Now you can just take yourself at your notebook, इसका सेक्शन लें और ये एक मोमेंट एक्सप्रेशन लिखें. Is it understandable? Please write this expression with your own handwriting. रोल नंबर 77 अपना माइक्रोफोन बंद कर दे, माइक अपना बंद करें.
चार्जर लगी सी लाइट बड़ी चूड़ आई हुन पैरी तेन रुकी गया यार चार्जर ला दे तू बात
जी इसमें कोई कंफ्यूजन है in writing the moment expression for portion CD?
No, sir.
Okay. Now the next thing is to take the partial derivative of this m value with respect to p. Now we will consider only the terms with p, nothing else. So it will be px by 2, यहाँ पे भी px by 2, यहाँ पे भी px by 2. So partial m over partial p will be x by 2, x by 2, and x by 2. Very simple. Now, what is the next? We have three portions. इस expression को अब आप portion wise लिखते चले जाएं. Deflection at D 1 over EI integral 0 to 1.8 80 plus P by 2 into X, that is capital M, into X by 2, that is partial M or partial P into dx. This is for portion AC. Now for portion CD, 1 over EI integral 1.8 to 2.7, 80 plus P by 2 into X minus 120 into X minus 1.8. This is capital M into X by 2, partial M or partial P into dx. Now lastly for portion BD, that is 1 over EI integral 0 to 2.7, 40 plus P by 2 into X. This is the value of the capital M into X by 2 into dx. Now we will equate P equal to 0 being fictitious, and rest of the integral will be solved. It is simply the mathematics. Please solve it yourself. Please switch on your cameras and solve it, please. Roll number 101, please switch off your mic.
अस्सलाम सर।
जी वसम।
सर आप ये बता दें सर, हम कब पार्शियल एम और पार्शियल पी यूज़ करेंगे और कब स्मॉल एम यूज़ करेंगे सर?
दोबारा पूछे, आप क्या पूछा आपने?
सर आपने इस प्रॉब्लम में जो सा एम का सिंपल पार्शियल डेरिवेटिव लेके आपने पार्शियल एम और पार्शियल पी निकाल लिया, लेकिन सर प्रॉब्लम नंबर 3 में आपने स्मॉल एम निकाला था वो यूनिट वेट रख के, यूनिट लोड लगा के।
आपने पिछला लेक्चर गौर से अटेंड किया था?
यस सर।
उसमें इस चीज के बारे में मैंने बताया था।
सर वो रिपीट कर दें तो सर।
नहीं, आप गौर क्यों नहीं करते हैं? Why don't you concentrate on your studies? ये रिकॉर्डिंग में भी होगा और ये वैसे भी मैंने इसको बताया है। Whenever there is the loading in generalized form like this P, MA, you can use the equation in this form. That is little, you can say it is more convenient. You can use any of these, जो दो forms हैं equations की, उनमें से किसी एक को use कर सकते हैं, but it is commonly more convenient. But whenever there is specific values or loads, small m is more convenient to use. जब स्टूडेंट्स की प्रायोरिटीज में स्टडी नंबर 1 पे होती है ना, उसकी कंसंट्रेशन इंप्रूव होती है, उसकी डेडिकेशन इंप्रूव होती है। प्लीज एवेल्युएट योरसेल्फ। फिर आपको जो एडवाइसेस हैं ये अच्छी नहीं लगती हैं, बट द प्रॉब्लम लाइज हियर। आपका ख्याल है कि ये दोनों जो इक्वेशंस हैं, ये मैंने मिस किया होगा कि ये कहाँ कन्वीनियंट है इस्तेमाल करना, ये कहाँ कन्वीनियंट है। और अगर ये बिल फर्ज एक लम्हे के लिए इसको इमेजिन भी कर लिया जाए, तो जहां इसकी एप्लीकेशन हो रही है वो आप देखें ना कि किस प्रॉब्लम में किस इक्वेशन की क्यों एप्लीकेशन हो रही है। दैट इज सेल्फ एविडेंट। So please increase your concentration if you can. So any other question?
नो सर, थैंक यू सर।
Anybody else? ये स्पेशली जो पोर्शन CD है, इसको आप वैसे एट योर एंड आप इसको जो है C ओरिजिन भी लेके इसको आप सॉल्व कीजिएगा। आंसर मस्ट बी सेम। जी, please hurry up and share the answer with me. जी, please hurry up.
सर आगे आंसर
जी आपकी आवाज कट रही है, दोबारा बोलें।
सर मैंने कहा है आंसर आ गया।
जी व्हाट इज योर आंसर?
सर 0.01479।
नहीं, ये इसकी यूनिट क्या है? इसको मिलीमीटर में कन्वर्ट करें और मुझे बताएं। जाहिर है डिफ्लेक्शन जो है वो मिलीमीटर में होगी, वो मीटरों में तो जाहिर है इसको लिखा जा सकता है, लेकिन अप्रोप्रिएट यूनिट इज मिलीमीटर।
सर 10.479 मिलीमीटर बनेगा।
10
479।
ठीक है, ठीक है। इट्स आंसर इज आई हैव रिटन 10.48। इट्स ओके। सो व्हाट अबाउट द अदर स्टूडेंट्स? जी बाकी स्टूडेंट्स का जवाब निकला है।
यस सर 10.476 आया मेरा तो।
ठीक है, देयर इज नो इशू if you have any change in the second decimal, that is possible. So yesterday I uploaded one numerical problem related to the deflection of beams. Have you seen that? I think none of you. So I'm going to share the screen of that. Let me. So if you look at this beam, we have to compute the deflection at point D here in terms of EI. Now, for your convenience, I have written the portions, origins, limits, capital M and small m, because there are specific values of loads and loads. So the answer has also been written in terms of EI. Now you have to solve this problem yourself. Now you know the names of reference books that contain on the page showing the tentative lecture delivery plan, 2 books. Now you have to solve all the relevant problems related to the deformations of beams from the reference books, and of course within the limits which have been taught. So maximum 3 portions, or you can proceed for maximum 4 portions, but on the similar lines. So you have this week and the next week of holidays. So with these 2 weeks, you have to complete all the problems related to the trusses. Actually, all problem which you have done by method of joints, you will do it from the method of sections. Irrespective of the method of analysis, the answer must be same. Now, these 5 problems on beams and similar problems given in the reference books. This you will complete on your notebooks. Then I will let you know how to share with me for evaluation. So with this problem, this topic is completed.